This is video number 10 from digital-university.org, considering different techniques of electrical circuit analysis. In this video, we want to use the mesh analysis and apply it to this circuit here. If we can get it in focus. Here you see we have a series of resistors, 1 ohm, 2 ohms, 3 ohms, 1 ohm, 2 ohms, hooked up to 2 batteries to give us this overall circuit. And to apply the method of mesh analysis, what we do is we look at these and we consider this as sort of separate windows in the circuit, if you will. And in each one of these windows, we consider a current flowing through it. And when we're setting the problem up, for example, this would be window 1, the current one flowing through it, and we're drawing the current as if it's flowing through this particular part of the circuit in a clockwise direction. And we set that way, and we set it up in like manner for this window and this window. So this would be current number 2, and this would be current number 3. Now, it might be that the current that flows through this resistor here may not be going in this direction. It might be going in the opposite direction. Or the current that flows through this part of the circuit, or current might be going in the opposite direction. That certainly is true, and if that is true, it will reveal itself later on when we do the number crunching part. But to set the problem up, what we do is we look at each individual window of the circuit, and we draw it as if there is a counterclockwise current flowing through that window. Another thing that we consider is that when a current flows through a resistor, that it enters the resistor at a higher potential and it exits the resistor at a lower potential. So we show it as a plus minus, because here current 1 is going to resistor 1 in this direction, and resistor 2 in this direction. So we designate this as a plus minus voltage drop. Now, for the current in the second window, that is current I2, again, going in a clockwise direction, it would enter the resistor at a higher potential than where it exits, so we designate a plus minus sign here. Same thing for this resistor, and same thing for this resistor. Now, for current number 3, down here in this window, again, we're showing it when we're setting up the problem, the initial analysis, if you will, to show this going in a clockwise direction. And again, enters the resistor at a higher potential than what it leaves the resistor, so a plus minus, and plus minus, like this. Now, when we go back to here then, what we do is we consider going around this first window or around this first loop, all the voltages sum to 0. Same here, and then same here in this loop. So here, current I1 is going in this direction, and from here then we'll be going across the battery like this, from the negative potential to the positive potential. So the first voltage that we would write down, we're going to leave the units off, just write the numbers down. Here we are in mesh 1. Then this is plus 7 volts. And again, we're not going to write down the units, just the number. Okay, now here we have I1 is going through the resistor number 1 and plus minus, so we have a voltage drop across here. So the current then that goes through this, we write this here as the voltage drop is plus minus, there's a voltage drop here. The magnitude of that voltage drop is the magnitude of the resistance, that's just 1, times the amount of current flowing through it. The amount of current flowing through it is I1 minus I2. Like this. Now, this current I1 continues to go down across this battery. Now we're going plus to minus, so that's minus 6 volts. And then it goes across this resistor with the voltage drop like this. So again, we consider with the voltage drop that is minus how much the voltage drop? The value of the resistor, which is 2, times the amount of current flowing through it, which is I1 minus I3. So this would be the sum of the voltages through this first window of the circuit, if you will, and they have to sum to 0. Now, before we go on and set up the currents for, or we set up the equations for mesh 2 and mesh 3, let's review first of all what we did for mesh 1. So again, we're assuming, to set the problem up, we're assuming that there is a clockwise current that flows down this resistor, straight down across the battery, down this resistor, and back up to the battery. That's our mesh current, if you will. And here, then, it's going in a clockwise direction, like this, going from negative to positive, or from a lower potential to a higher potential in this direction, so that's designated with a positive voltage. Here, that goes across the battery, this mesh current, it's going from a higher potential to a lower potential, so that's designated with a negative voltage. Same thing when it goes across resistor 1, a resistor value of 1 ohm, and when it goes across this resistor. We're assuming, yes, it enters at a higher potential, leaves at a lower potential. So when we ask how much is the voltage drop across this resistor, the fact that it's going from plus to minus is designated with a minus 1, the value of the resistor, times the amount of current flowing through it, which is I1 minus current I2. Here, again, a voltage drop, so we designate that as minus 2, the value of the resistor, times the amount of current flowing through it, which is I1 minus I3. So here we have a plus voltage drop, if you will. We're going from minus to plus. Here we have a negative voltage drop going from plus to minus. Here we have a negative voltage drop going from plus to minus, and across the resistor, a negative voltage drop going from plus to minus. And of course, for the resistors, the voltage drop is equal to the resistance times the amount of current going through the resistor, which we have shown like this. So that's the equation for mesh 1, and if you go ahead, just do some simple algebra and correct the terms, you end up with this equation. So this is the net result from the mesh 1 current, this equation right here. Now, let's go ahead and set it up for the second mesh. So here is the second mesh like this, and we can see, well, now for this current, it goes across plus minus, plus minus, plus minus. So all of these have voltage drops. So all these will be designated with a negative sign. But here then what we have is for the voltage drop across this resistor, it's the value of the resistor, and we have a minus sign by it. And it's going through a voltage drop. Now how much of a voltage drop? Well, it's the value of the resistor times the amount of current going through it. But now, when we're in this window, or in this mesh current, now we say it's I2 minus I1. Try to keep things in focus here. Okay, we are considering just this resistor right here going from plus to minus. So that's a voltage drop, so we have a minus sign. And how much of a voltage drop? The value of the resistor, which is just 1 ohm. Only now, we're working with this mesh current. So now we say it is I2 minus I1. Written like this. When we were in this mesh here, we were looking at current I1, we consider it to be I1 minus I2. Now here, we're looking at this current going across the resistor. Here we consider it as the value of the resistor times I2 minus I1. With a negative sign before it because it's going across that voltage drop. Okay. Now, we have I2 goes across that resistor, and that's just, again, a voltage drop. How much of a voltage drop? First of all, the minus sign, because it is a voltage drop. The amount of the resistance, 2 times the current going through it, and that's just I2. Then we have, it goes also through this resistor, again, a voltage drop. So a negative sign. How much of a voltage drop? The value of the resistance times the amount of current going through the resistor. Now here, in this case, we consider as I2 minus I3. So we have I2 minus I3. Equals 0. Now, if you just go ahead and do some simple calculus, or calculate just some simple algebra, and collect the terms, what you get from this equation is minus I1 plus 6 times I2 minus 3 times I3 equals 0. So that's our second mesh equation. And again, in each one of these windows, with each one of these meshes that we're working with, we're considering all the voltage drops. And in each one of these windows, when you go all the way around, the voltages add up to 0, which is what we're showing here. And likewise, right here. Now, we have to consider the current that is going through mesh current going through this window right here. And looks like we may not have enough room, so let's go ahead and make some room. Now we're considering mesh current number 3. Again, that's this one right here. So here we are, clockwise current that goes like this. These resistors and across the battery. And notice now when it goes across the battery, it goes from minus to plus, or from a lesser potential to a higher potential. So when we write the equations, this is designated as a positive voltage drop. All the other ones, plus to minus, plus to minus, plus to minus, are negative voltage drops. So let's go ahead then and see if we can write these in. Let's start here. So we have, it's going across resistor 2 with a negative voltage drop. So we designate this with a minus sign. How much of a voltage drop? The value of the resistor times the amount of current going through it. Now here, we're working with mesh current I3, so we say it's I3 minus I1. I3 minus I1. Then it goes with a positive voltage drop, so that's plus 6. Okay, now negative voltage drop. This is 3 ohms. So here then it's going to be minus 3. And how much is the voltage drop? It is I3 minus I2. Like this. Then finally it goes through this resistor. There's no other currents going through it. It is a voltage drop. So we designate that with a minus sign. Minus, and how much is the voltage drop? The value of the resistor, which is 1 ohm, times the amount of current going through it, which is just I3. And again, all the voltage drops add up to 0 in each one of these meshes. So this is it now for mesh number 3. And again, go across, do simple algebra, collect your terms, and you end up with this expression, minus 2 I1 minus 3 times I2 plus 6 times I3 equals positive 6. Putting this over here makes it negative. When you do your algebra multiply through by a negative 1, you come up with this expression. So we have this equation. So where things stand right now is that we went through windows 1 through 3, working with 3 meshes, and what we obtained are 3 equations. We have this equation, that's equal to 6. We have this equation for mesh 1, that's being equal to 1, and we have for mesh 2, this equation being equal to 0. So here, in the way we set this up, there are 3 currents to solve for, I1, I2, and I3. here we have 1, 2, 3 independent equations to solve for this. So come back, join us for the next video, and we'll go ahead then and solve these simultaneous equations.